Welcome viewers. In this video we'll see the number based conversion, second type, successive multiplication, that is converting from binary to decimal, octal to decimal, hexadecimal to decimal. In this video we'll see the binary to decimal. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. Binary to decimal. Binary means the base is 2. Decimal is base is 10. So we are converting from base 2 to base 10. Decimal to binary to decimal. We'll see two examples. First we'll see the example 1. The binary number given is 101111. Right? So while converting we got 47. We'll see how we got the 47. The decimal number we got 47. So this 10111 is written. So how to convert it is multiplied by the successive multiplication. The topic is a successive multiplication. It should multiply with the weightage. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4 and 2 to the power 5. So starting from LSB, this is the LSB, least significant bit. This is MSB. Starting from LSB, we need to multiply with 2 to the power 0, 0, 1, 2, 3 like that. Now we'll write it separately. 1 into 2 to the power 5. Then 0 into 2 to the power 4. 1 into 2 to the power 3. 1 into 2 to the power 2. 1 into 2 to the power 1. 1 into 2 to the power 0. Right? So we need to multiply the given decimal number. Starting from the LSB, we will multiply with 2 to the power, weightage 2 to the power 0 to 1. So these are all multiplied and written. So 1 into 2 to the power 5 means 2 to the power 5. The 0, so it becomes 0. This is 2 to the power 3. 1 is there. So 1 into 2 to the power 2, 2 to the power 2, 2 to the power 1 and 2 to the power 0. So 2 to the power 5 is 32 plus 0. The digit is 0. 2 to the power 3 is 8. 2 to the power 2 is 4. 2 to the power 1 is 2 and 2 to the power 1 is 1. 2 to the power 0 is 1. So while adding all this value we got 47. So the decimal equivalent of the binary number 10111 is nothing but 47. So how we are calculating? We are going for the multiplication. It is multiplied with the weightage 2 to the power, starting from 2 to the power 0, 1, 2 like that. Now we need to multiply all. By adding all this we'll got the decimal number. Right? Now we'll go to the second example. In the second example, the binary number given us 101.1101. So the decimal available in that binary, we have decimal available. Example 1 not having any decimal. Now example 2 is given with a decimal point. So while converting this binary, we got 5.8125. The decimal, the binary, the decimal equivalent is 5.8125. We'll see how we are got 5.8125. Now we'll write the decimal number 101.1101. Right? The decimal number is written. Here we have the point is available. Now starting from here, this is LSB and this is MSB and this is the decimal points. Right? So starting from here, you multiply with 2 to the power 0, 2 to the power 1 and 2 to the power 2. Very similar to previous example. So while going with the decimal points, it is 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3 and 2 to the power minus 4. Right? So starting from here 0, 1, 2, 3 like 4 like that. After this decimal point it is given in a negative 2 to the power minus 1, minus 2, minus 3, minus 4. Right? So it is given in the, it is multiplied with this weightage. Here 0, 1, 2, here minus 1, minus 2, minus 3. Right? Now we'll multiply this 1 into 2 to the power 2, 0 into 2 to the power 1. 1 into 2 to the power 0 dot. What is available here? 1 into 2 to the power minus 1. 2 to the power minus 1 means 1 by 2. 2 to the power minus 3 means it is 2 to the power minus 1 means 1 by 2. 2 to the power minus 2 means 1 by 4. So 1 into 1 by 4. Then 0. 0 into 2 to the power minus 3. 2 to the power minus 3 means 1 divided by 2 to the power 3, that is 0. Because 0 it is not given. 2 to the power minus 4 means 1 into 1 divided by 2 to the power minus 4, 2 to the power plus 4, 2 to the power 4 is 16, right? 2 to the power 1 divided by 2 to the power is 1 divided by 16, right? So it is 1 into 1 by 2, 1 into 1 by 4, here 0, here 1 into 1 by 16. This is nothing but 2 to the power minus 1. This is 2 to the power minus 2. This 2 to the power minus 3 is 0. 2 to the power minus 4 is 1 by 16, right? So here we got 2 to the power 0, 1, 2. Here we got 2 to the power minus 1, minus 2. Minus 1, so that it got 1 by 2, 1 by 4, 1 by 8, that is 0. 1 by 16, right? Right. Now we need to simplify this. So 1 into 2 to the power 2 means 2 to the power 2. This is 0. This value is 0. Then 1 into 2 to the power 0 dot. This is 1 by 2. This is 1 by 4. This is 1 by 6. 1 by 16. So 2 to the power 4 means 4. 2 to the power 2. 0. The 2 to the power 0 means 1. Right? Okay. This decimal point. We need to take the LCM. 16. The LCM of this 16. Right? The 16, the 2 is go 8 times. So it is given as 8 plus. Then 16, the 4 is given. 4 is goes 4 times. So it is 4. Here 16 is available, so it is 1. So normal LCM, normal simplification of fraction number, right? The LCM is taken between 2, 4, 16. That LCM is 16. The 16 is goes in 2, it goes 8 times, so it is given 8. The 16 goes 4 times in 4, so it is given 4. 16 goes 1 time, it is given 1, right? Now we got this value. So 4 plus 1, 5. 4 plus 1, 5. Then while simplifying this, 8 plus 4 plus 1 is nothing but 12 plus 1, 13. 13 divided by 16, right? So 5.13 divided by 16, right? So 13 divided by 16 is nothing but 8125, right? So 5.8125 is the final value, right? So the binary equivalent of this decimal equivalent is 5.8125. So in this decimal available, what we are doing? So it's starting from here 2 to the power 0, 1, 2. This side minus 1, minus 2, minus 3, minus 4. 2 to the power minus 1 means 1 by 2. 2 to the power minus 2 means 1 divided by 4. 1 divided by 2 to the power 2 means 1 by 4. This is 1 by 8. This is 1 by 16. Right? So that we are multiplying all these values, then we are going for simplification, step by step simplified. This whole number as well as decimal numbers are simplified. Finally we got 4 plus 1, 5. Then this 8 plus 4 plus 2, 8 plus 4, 12, 12 plus 1, 13 by 16, it is 5.8125. So this is the decimal equivalent of the given binary number. So in this video we discussed two problems. One is normal binary number, another one binary number having decimal points, right? So both we got the decimal equivalent, right? Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. In the consecutive video, other conversion system also available. Thank you for listening.